My name is Brad. I'm a CFI at Thrust here in Addison. Today we're going to go over the 4 principles of flight: thrust, lift, weight, and drag. Dan, one of our AMT instructors, is also going to mirror this and show you the same things that I'm talking about on the real aircraft.
All right, welcome back to the hangar. My name is Dan. I am an AMT instructor here at Thrust Institute of Maintenance. Earlier, Brad was discussing the 4 forces of flight on an aircraft. He was talking about an Archer II, which is made by Piper, very similar to the plane that's right behind us, which is the Piper Cherokee. But today we're going to be talking about this Grumman Yankee. So, what are the 4 forces of flight? We've got lift, drag, weight, and thrust.
So we'll go ahead and start with lift, which is the primary reason that we're able to fly, right? Our aircraft and our wings generate lift, and they're able to keep us airborne with the air that flows both over them and underneath them. So there's a principle called Bernoulli's principle. So high pressure always wants to seek low pressure. That's the way that it works. And so when we have Bernoulli's principle in play, it's telling us that the higher the speed of a fluid, which in air is fluid, it's going to move faster, right? Lower pressure. So that higher speed over the top of the wing causes low pressure, and high pressure wants to seek low pressure. So our wings are curved on the top, and therefore the air is actually able to speed up going over them. So it has lower pressure, and then we have high pressure underneath the wing. And what that does is it drives the force of that wing upward and generates lift for us. So that's what allows us to literally fly through the air. Our wings are the primary generator of lift that we have, right? But it's also other airfoil surfaces that we have as well, like our stabilator in the rear of the aircraft.
Where are we getting our lift from? Right here, our elevator. In the Archer II, it's going to have a stabilator, which is a combination of our stabilizer and our elevator.
But the wings do the primary job of generating the lift. But on top of that, we need also something to help keep that airflow over the wings and propel us forward. So that's where thrust comes into play.
Thrust is obviously controlled by the propeller, right? Just like the name says right here.
You know, jets have their jet engines that generate thrust, but our propeller is in the front of the aircraft, and that thrust is generated in the direction that the propeller is pointing. So we have a forward propeller on the nose of the aircraft that allows airflow to go over the fuselage, over and underneath the wings, and generate that lift.
Again, we have our propeller in the front right here. We have a leading edge and a trailing edge. Again, leading right here, trailing right here. The prop acts like an airfoil, just like a wing. The way that we're converting lift on a prop into thrust is it is cutting through the air at a specified RPM, and it is throwing air in behind the prop to create our thrust so we have propulsion.
Yeah, so you have, of course, also weight, right? And weight just works off the principle of gravity. And what we have in the aircraft is we have something called the center of gravity, which is like a pivot point of the aircraft. And that's where we base all of our performance and weight and balance calculations off of, is the center of gravity. Just like dropping a ball from, standing height, it wants to fall towards the earth, so does the aircraft. So we need both thrust and lift to fight the force of the weight. And that's what's also going to propel us forward, keep us flying through the air. When you have all forces in equilibrium, that's how you maintain straight and level flight, where you're not climbing, you're not descending, you're not speeding up, you're not slowing down. So when all 4 are in harmony, you're able to maintain that level flight state. So with weight, it's just pretty much the same simple principle of dropping a ball, right? The aircraft wants to go down. The weight is consistent of the passengers, the payload, the fuel, the aircraft itself, anything else you have on board is wanting to pull itself down towards the earth just based on the principle of gravity. And we need excess thrust and lift to keep that from happening. So drag is going to be what is stopping us from speeding up, in simple terms. So if you've ever stuck your hand out the car window, when you face it flat out the car window, you know how it flies back, right? So that's basically, you're creating drag, right? Which is causing the air to deflect against that surface and push it backwards.
Or just like your hand outside of your car when you're driving about 45 miles an hour, where you can pitch it up and down to get lift.
So the thrust always has to be greater than the drag to be able to propel the aircraft forward. If you want to maintain your current speed, you don't need excess thrust. There's just enough thrust and just enough drag to keep your aircraft flying at a constant speed. Right, so that's the whole equilibrium state of flight, maintaining straight and level, not speeding up, not slowing down. Obviously, you have to take into consideration all of those four forces constantly, but it's not something you have to be conscious of, right? You can just think of that subconsciously because you're primarily focused on flying the aircraft. Those 4 forces are occurring around you at all times. It's not something that you are necessarily having a direct control over. But when we fly things like a traffic pattern, we need to make sure that we have enough thrust to generate our airspeed, which gives us enough lift to take off. So in the Piper Archer that we have at thrust, we go for 60 knots for our rotation speed. And at 60 knots indicated, we know that we have enough lift where we can go ahead and pull back on the controls, and we can then take off and start flying the aircraft. So you need to understand that important relationship where if you take away the thrust, the aircraft is going to want to go down based on its weight. We need to counter that by moving the control surfaces to the back so we can generate more lift, right? That's a prime example. Another great example I've seen is we do a steep turn maneuver as part of private pilot rating, as part of the commercial pilot rating. And when you're doing those steep turns, you're banking 45 up to 50 degrees of bank. You lose a lot of the vertical component of lift when you start banking that steep. So the nose actually wants to drop and the aircraft wants to slow down. So what you need to do is you need to introduce more thrust. And that will help keep your speed up, help keeps your nose up so you don't drop speed, you don't drop the nose and descend during the maneuver. So you're not directly thinking like, okay, I need to generate more lift. You just know as a pilot, that means I need to add more power, right? I need to pull back on the controls. So that's how we think of them in the airplane.
All right, so here we are in the cockpit now. We've got our yoke, which controls our ailerons left to right. It also controls our pitch with our elevator going forward and back. We got down pitch, we got up, we got right, we got left. Control our yaw with our rudder. We are using our rudder pedals down on the ground. As you can see, they're connected from one side to the next, so either person in the cockpit can control the rudder.
So we have primary control surfaces. We have both the stabilator, which is located in the rear of the aircraft on the tail. We have ailerons, and we have our rudder, and those would be the primary control surfaces that we have, right? So the ailerons are located on the outer portion of the wing, and those are going to deflect either up or down, depending on the direction that you're turning in. And what that's going to do is it's going to push the air in that direction that you need to go in. So if you're banking to the right, you're going to move the controls to the right ailerons are going to go up, right? That helps deflect that wing down. And then the left ailerons are going to deflect down, which helps to raise that wing up. And so those move in conjunction with the yoke that we use to fly.
We've got our ailerons right here. That's going to give us our roll axis.
We also have the rudder, which we control with our pedals, and that controls the direction of the nose of the aircraft, the yaw.
Our rudder is going to control our yaw, which that is the sideways motion of the tail.
And then we also have our stabilator, which is also known in other forms as an elevator, for example. And that is what we control with the yoke forward and backwards. That controls our pitch of the aircraft. So if we're talking in regards to lifts or countering things like weight, we need to either use that to pull up and raise the nose or push it forward and lower the nose. In essence, right, it's the way that we control the aircraft. So in totality, yeah, it is how we manipulate our aircraft against those four forces and help either fight them or work with them to maintain flight.
Again, my name is Dan. Just wanted to give you a live demonstration on how the four forces of flight are acted upon an aircraft. Thanks for joining me in the hangar. Until next time.
If you guys like this sort of content, make sure to let us know in the comments, and please make sure to like, comment, and subscribe.